Alright, I'm going to do the second page of the S2F diagonal lengths and angles inside 3D shapes. Okay, so in this problem, we're trying to find the angle between the following line and the base plane, which is EFGH. So that's the bottom of this shape here. Okay, so the bottom of the shape is this right here. Okay, so the floor of the box. So we want to find the length of this blue line with the floor of the box. So first I found out the length of the blue line, which is 4 squared plus 6 squared. Take the square root of that, and the length of the blue line is 7.211. Okay, and then the base here, we already know that the length here is 6. So to figure out the length, the angle between DG and the base, I'm trying to find angle DGH. So I draw my right triangle, because this is a right triangle right there at H, and I know this is 7.211. I know this is 6, so I've got the hypotenuse and adjacent. Using SOHCAHTOA, I'm going to use cosine if I have opposite and adjacent. Divide that fraction, I get this decimal, and I do inverse cos, and I get this answer. Okay, you may want to hit pause to think about this for a minute. Okay, next I want to find the angle between BH and the base here. So this cuts the box diagonally. So I need the length of BH, and since it's in 3 dimensions, from one corner to the other corner, I have to do 6 squared plus 5 squared plus 4 squared, which gives me 77. Square root of that, the length of the orange line is 8.775. Okay, now I'm trying to make a right triangle, and I've got BHF is my right triangle, BHF. Well, I don't know the length of HF at the moment. I could have found the length of HF using Pythagorean Theorem, but I already know that BF is 4. So I just used the 4 that I was already given. So if I've got the hypotenuse and the height 4, and I'm trying to find this angle BHF, then I'm going to use opposite and hypotenuse. I'm going to use sine. Find the ratio, get my decimal, do my second cos inverse of sine, and I get my angle. Okay, next problem. You may want to hit pause if you need more time on that. Okay, so find the length of diagonal DF. So D to F, it goes diagonally in the box. So 6 squared plus 5 squared plus 4 squared, add those together, take the square root. The length from D to F is 8.77. Okay, find the size of angle BDF. So B to D to F. Okay, so to find the angle from B to D to F, well, we know that BD F to B to D, that angle right there is going to be a right angle. And we already know that BF is a length of 6, and we just found out that D to F is 8.77. So I've got opposite and hypotenuse. I'm going to use sine, which is opposite over hypotenuse. We convert that to a decimal. We do our inverse sine, hitting second sine, and then we get our angle. Okay? You may want to hit pause to copy this down. Okay, number 19. Okay, so we've got a cuboid with lengths 4 and 5 and 6. Now the way that this was drawn in the paper, it said 6 centimeters right there, which looked misleading because 6 centimeters is from here all the way down to here. So I just kind of rewrote this and wrote a 3 here, because from here to here is 3. Okay, according to this information here. Okay, M and N are the midpoints. So, so now this, we want to find the angle of NEM, N to E to M. Now because of the way this is drawn, it's kind of cut at a weird angle, so there's no angles in here that are right angles. So I needed to find the length of all three sides, and then once I find the length of all three sides, I'm going to find the angle using the law of cosine. So step one, let's find the length of all three sides. So to find the length of the blue side, we know that that's 4. We know that that's 3 because M is the midpoint. So 4 squared plus 3 squared, take the square root of that. The length of the blue line here is 5. Okay, the length from N to E. So once again, this is halfway down, so I know that's 3 and that's 5. Using Pythagorean Theorem, we're going to get 5.83. Now the length from M to N seems kind of tricky, but if you think about it, it's the same length as from B to D, because these lines are parallel, it's just up above it. And so to figure out the length from B to D, it's going to be 5 squared plus 4 squared, add those together, square root, and you get 6.403. So now I'm going to take, using the law of cosine, I'm going to take the two sides on either side of the angle, square them and add them. So 5 squared plus 5.83 squared minus the angle, the side that's across from the angle, which is 6.403 squared, divided by 2 times the sides on either side of the angle. Okay, so I simplify all this, and I get 5 squared is this, 5.83 squared is this, 6.403 squared is this, 2 times this gives me this. Simplify the ratio, and we get this decimal, and second cosine, and we get 72.0 degrees. Okay, next problem. You may want to hit pause if you need more time to think about this. Okay, question 3. Okay, for each of the following figures, find the angle between the given segment and the base. Okay, so the first given segment is x to d, which is the edge of the pyramid, and from the picture here, we can see the edge of the pyramid is 15. Okay, so we know that's 15, and the base here, the right angle is with M, so we've got XDM, and so we know that that's the right angle there with X and M and D, and I need this length here of the pink line to get my angle here. Now so first thing I had to do was I needed to find the length of DM, but using the information I have here, it was easiest, the only thing I could do was to find the length from D to B. So 12 squared plus 10 squared, add them together, take the square root, and I ended up the length of D to B is 15.62. Now D to M is half that length, so I divide that by 2 and I get 7.81. Okay, so now I know this is 7.81, and I know this is 5, and I got the angle here, so I'm going to use adjacent and hypotenuse. I'm going to have to use cosine. So set up the ratio, adjacent over hypotenuse, and then I get my decimal, and then I do second or the inverse cosine, and we get this answer here. You may want to hit pause. Let's look at question II. Solve for xy. This one was a little bit trickier. So xy is this side right here. So we don't know that length, and we know we have to do xy to m. So I don't know the length of m. I don't know the length of xy. And from x to m, we don't know that length either. So the first thing I did is I found the length of x to m. So we knew from this previous picture that this was 15 and this was 7.8. So I figured out the height, xm, using Pythagorean Theorem. So I've got this squared plus xm squared is equal to the hypotenuse squared, which is 15 squared. And then I subtracted 7.81 squared on both sides. Then I took the square root of both sides to get x. And then 15 squared minus 7.81 squared is going to give me 164 approximately. Take the square root of that, and I get 2.8 for this value. And, sorry, 12.8. So that's where I wrote this here. Okay. So I figured out this value from here. Okay. So next, I needed to figure out the length of xy. So if I look here at this triangle here, xy can be found. It's the height here of triangle xyb. So I redrew x, y, b right here, and we're trying to figure out this height. We know the edge of the pyramid is 15, and we know the distance from here to here is 5. So I can do 5 squared minus 5, 15 squared minus 5 squared is going to give me this height squared. And I square those and subtract them because 15 squared is the hypotenuse. And then we get square root of 200. And so then I figure out this height of this triangle is 14.14. Now that I know that this is 14.14, I can solve for this angle here. I've got the opposite side, I've got the hypotenuse, so I'm going to use sine, set up the ratio, do second sine on the calculator, or inverse sine, and now I've got the angle. I'm going to do the third page on a different video.